In 2's complement, we also need to be comfortable with converting denary numbers into their binary equivalents. So let's do a few practice. So if you feel you've understood it from the explanation, feel free to pause the video and try it out for yourself. So if we want to represent negative 103, the first thing that we've got to do is represent positive 103. So that would be 96 plus another 7. And this would give us positive 103, which is obviously not the answer that we're looking for. Hopefully you can remember that the first step that we go through, it was to invert all the 1s and 0s. So 0s become 1s, 1s become 0s. And then we have to add 1 on. And this has been actually quite a nice one, because 0 plus 1 from our rules of addition is 1 with no carryover. So we can actually just copy down the answer that we had without making any other changes. And that would be the binary representation of negative 103. Now the thing to check is to make sure when you're representing a negative number that your most significant bit is a 1. Try some others. Let's try and do negative 42. So again, pause the video to practice and make sure you can get it correct, or watch the video once, pause and try again. So we want to get positive 42 first of all. So 0, 0, 1, 0, 1, 0, 1, 0 to give us 42. We then invert, so the 1s become 0s, the 0s become 1s. Now take your time doing that because it's very easy to make silly mistakes. Then we add 1 on, and we'll get some carryover this time, because 1 plus 1 is 2 in denary, but in binary that gives us a 1 carryover with a 0. 0 plus the 1 is 1 with no more carryover, and then we just copy down the rest of the number without making any changes, and then that gives us negative 42 in 2's complement. Now just looking at the number possibilities, we can still represent positive numbers using 2's complement, and the way to check is that if there's a 0 or 1 at the front, so the highest positive number that we can get is 0 and all 1s, which gives us positive 127. Now by the same idea, using the same principle, we can work out what the lowest negative number that we can represent is. And that's actually represented by this number. And let's just work out what it is. We invert, we add 1, and we get lots of carries here, so we get 0 with 1, 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 1 plus 0 is 1. And we can work out that that's negative 128, which is the lowest negative number you can achieve with 2's complement. To give us the lowest negative number, there would need to be a 1 at the front in order to ensure that it's negative, and it would have to be 1, 1, 1, 1, 1, 1, 0, so that when we add 1 on here,